So now we will discuss about the assignment 6 solutions which all of you have submitted. So if you look at the very first problem, so just by seeing of the problem can some of you tell that like how will you approach the problem. So it's a box, and inside that frame there is a slender rod, okay, and the slender rod have a roller at the two end, and the question is that at what acceleration that the frame should be so that the roller will rest with the frame in that position only. That means when this theta equals to 45 degree and this slender rod with the roller will not move at all. At what acceleration it should be move that entire frame so that the roller will not move inside the frame. So can any of you like suggest something, because all of you submitted the assignment, right? So any thoughts? It's a very simple problem, and the hints is that you need to solve the problems in a different frame of reference, which is not the frame of reference which is outside the frame. So can any of you like suggest something that how will you solve it? And it's only 2-line solution. That is also there. Anyone? So before going into the details of the problems, you just think that if you see from the outside, you might look like that when that frame is accelerating, then that slender rod might also like move within the frame. But if you attach an a frame of reference, if you see this entire thing in a frame of reference where you are also attached to that slender rod, then what will you see? That the slender rod is not moving at all. That means you can simply use that the slender rod is moving with the same acceleration as that of the entire frame. If that is the case, then it will not move at all. So let me like show you the solution. So okay, are you able to see the screen, the solution screen?
Yes, sir.
Okay. So now if you choose a frame accelerating with that cart or that box, then the FVD will look like this. And here again we are neglecting friction. There is no friction with the roller and the wall of the frame. We are just completely neglecting it. So if we neglect that, then you have the normal force on just both the roller, which is perpendicular to that surface, okay, and you have two roller, and this AB is the slender rod. In this figure, this AB is the slender rod. So let me check if I can do this. So this AB is the slender rod. 1 minute. Okay, so this AB is the slender rod. This one is the slender rod, and you have the normal force which acting on this N1 N2. Okay, you have the mass of the slender rod, which is mg, and if that entire frame accelerate with the A along this direction, then the acceleration of that rod will be in the opposite directions, as you know. this is, you know the pseudo acceleration, I guess all of you know, right? It will be the exactly in the opposite direction. So that is how it will, this free body diagram looks like. Okay, so then if you see that now that entire problem now comes to, like, you need to apply the Newton's second law of motion, that mass into acceleration is the net force acting on the system. So if you see the first expression, what is that? So I am just taking the forces along the x direction. So what are the forces along x direction? N1 and this MA. That's all. Only these two forces, right? So that means that summation fx must be 0, because you are in the same frame of reference, and you will see that the rod is static. It's not moving at all. Or the acceleration which it will have is this m into a must balance with that n1 term. That is what, if you do the summation fx equals to 0, or if you apply the Newton's second law of motion along x directions, it should be that mass into acceleration is the force, which is m into a. M into a is equals to n1. That's the Newton's second law. And if you do the same thing for the, like, y direction, then it's very simple, that the mass of the slender rod will be balanced by the normal component of the force, which is n2. So that n2 equals to mg, and this equals to this. Then this is the midpoint of the rod along which the gravity is acting. Okay. Now if you take a moment about the point O, where the acceleration of that entire frame or that rod, okay, not the entire frame, only the rod is going. If you take a moment about this point O, so what will you get? And this angle is 45 degree, by the way. Okay, so if this is 45 degree, you are taking moment about this point O, so you don't need to bother about what are the forces which are going through that point. So only you have 2 points, that is two forces, N1 and the N2. So N2 into, it should be, you are taking about this point, so it should be L by 2. So it should be this should be only this direction. Sorry, if I take a moment about this, it should be the this direction. So this is L by 2. Fine. So what is this distance? L by 2 into
L by 2 cos 40.
L by 2 cos 45, right? So if you do that, so it is L by 2 cos 45, and what about this case? It is again this direction, so only this distance, and if this is 45, this is 45, so this should be the again L by 2 sin 45, and it's the same thing. That means you are getting that the N1 is equals to N2. So if N1 equal to N2, then so you are getting N1 equals to N2, and sorry, you are getting N1, so you are getting N1 equal to N2. So if N1 equals to M2, then M into A should be M into Z, that is A is equals to Z. That means what it gives is that if the entire frame accelerate with the same acceleration as the gravity of acceleration, I mean the acceleration due to gravity, that the rod will not move. That's what it says in this problem. Okay, so before going into that any more details problem, I just wanted to give some end-end questions which will be like, you might, because again I'll talk about frictions and all. after the okay. In that case, let me first discuss the second problem, and then we will go through it. Because in the if I remember correctly, in the ancient problem there are multiple problems with the friction with the single roller rolling with the velocity. What is the uh, velocity at the point of contact? What is the velocity at the top? That I will just discuss. So let me go through the second problem first. I kept it in mind to discuss. So yeah. So this is again, it's not a just a free body diagram you need to draw, and will be done. So what is that? That the m is the mass of the cart, and m is the mass of the homogeneous cylinder. That is this. Okay, and then if P is the minimum force required for the homogeneous cylinder to begin roll off out of its rectangular recess, then what is the value of P divided by m plus m into z square? So how will you approach this problem without going into the detailed solution? Anyone? So what are the forces which is acting? So what are the forces which is acting? And again, for the simplicity, I am not assuming any friction. Now you tell that what are the forces which is acting, and like how will you solve the problem? It's again only the Newton's second law. Okay, that mass into acceleration is the net force acting on the system. That's all. Yeah. So when will you apply the force in this direction? Like what do you expect the cylinder to do? In the very first class, I solved a problem that, like, if you have a like a obstacle somewhere, and then you are pushing the cylinder, like what will be that minimum force, so that it will be able to overcome that obstacle and start rolling about that point. So let me see if I can show that thing. 1 minute.
Cylinder will have single.
Yeah, I was just talking about this problem. Can you see the screen? So that
Yes,
now
sir.
now here it has an obstacle, but you are forcing the cylinder here to make it go through, but there it's in a rectangular recess, and you are accelerating the entire recess. Okay, you are applying the force on the recess, not on that roller. So what do you expect from, like, and again the question is the same, that it will begin roll off out of the rectangular recess. That means when it will go through, it will roll off at this point, at the point where it will be like this, that the roller, and with the recess this about this point, the roller will start rotate, because the acceleration of that center of mass of the roller will be in the opposite direction, not in the same direction. So let me go through the solution. Let's see. So now you have both the roller and the cylinder. And the frame. That means the rectangular recess here. So if you put some force, and you don't need to bother about that what is that internally, what is moving and what is not moving, because that roller is within that, like roller also belongs to that system. I mean, if I consider that the uh, the rectangular recess and the roller as a system, and you are applying some force which is P, and the total mass of the system is capital M plus small m. So what is the acceleration of the system? It is P divided by M plus m, as simple as that, right? That the mass into acceleration of the system is equals to the external force applied on the system. That's the Newton's second law. This is this quantity, okay? That the mass into acceleration is equal to total force which is applying on the system. Fine with this. Now you have to change the frame of reference. So how will you change the frame of reference? That observing from a frame moving with acceleration a along the cart. That means now you are sitting from, like, you are observing the entire thing from outside, that I have a cylinder and a cart or the frame which is moving, and this will be the acceleration of the entire thing. Now you are putting yourself on that frame which is also moving with the, like, acceleration a, okay? So now you have to do the like apply the force balance or the Newton's second law for this entire system. So again, as I said, that this is that point of contact, because the m into a of that entire thing will act in this direction. This is the m into a, okay, as far as the roller is concerned. But when you see from the outside, if you observe that entire system from the outside, it is moving, then from outside the entire system is moving with some acceleration which is in this direction. But if you attach yourself, or if you put yourself on that roller, or on that frame, on that rectangular recess, if you put yourself and then see the roller, you will see that the roller is moving with the exactly same acceleration in the opposite direction. That is why that the encounter will happen at this point. Encounter will happen at this point. That the roller will start roll about the point on that rectangular recess which is in the opposite direction to that of the direction of external force, okay? So now you just draw the free body diagram and then tell me that what should be that different so the question is that what should be that P divided by m plus m square into g square, like what will be that quantity, okay? So when the cylinder is about to roll, the contact force N2 will be 0, because again like the previous case, that this because it will leave that surface. When it will start roll about this point of contact will be detached, okay? I mean, this point will be detached from the surface of the frame. So that means there will be no force which will experience in this direction, okay? So this N2 is equals to 0, and these are the different forces. Now you tell me that the different dimensions are given, that this is r by 2, this is also r by 2. Am I right? Those dimensions are correct, right? Yeah. So this is r by 2, this is also r by 2. So now what you need to do is that you need to take the moment about this point. I'll just show you that. You just need to take moment about this. You just need to take moment about this point. That's all. So if you take moment about this point, so what are the different forces? So that means at this point, whether the friction like you don't need to consider friction here because you are taking moment about that point, so it doesn't matter. Okay, so what are the forces that will act if you take moment about this point? It's only mass into acceleration and the m into g. So then what are the two distance from the geometry? Can someone tell? That one is, if
One is r by 2, other is r sin theta.
one is r by 2 and other is r sin theta. Okay, fair enough, because that yeah, because that distance is r by 2, this distance is r by 2, and you are taking moment about this point, so ma into r by 2, yes, ma into r by 2, and this mg should be this distance. So how will you calculate this distance? So this is r by 2, right, and this is r. So what will be this? This is r by 2 and this is r. So what is this?
Root of r square minus r
r by
square by 4.
r square by 4, right? So if you do that, I think this is something which you will get, that cos theta is equals to root 3 by 2. If you now calculate that angle, it will be 2, it will be this, and a is coming as g root 3. Okay, the acceleration of that cylinder, which is same as the acceleration, like magnitude of the both is the same. The entire frame is moving with some acceleration along with the cylinder, and if you sit on the frame and then observe the cylinder, you will see that the cylinder is, you will see that the cylinder is actually from the outside you will see that the cylinder is moving in the opposite direction, but from the frame you can take it into account that the cylinder is as if moving. There will be a force, pseudo force on the cylinder, which is acting in the opposite direction, which is m into a. That is what the like whole concept is. Okay, so that means this g is equals to a is equals to g root 3. If you do that, so it is coming as 3. Fine. Did you understand the basic philosophy? That is what, it is important that you have now two components. Like in both the problems, you have a frame. The entire frame is moving with some accelerations, and inside the frame there are objects which might also move. In the first problem, it was a slender rod with the roller at the two ends, and in the second problem, it's just a cylinder which will start to roll up about some point on the rectangular frame. So in both the cases, if you see from outside that you are just applying some force on the system, it will accelerate, and that acceleration should be that external force divided by the total mass of the system. That is what is valid for both the problems I discussed, and it is valid for all the problems. Okay, now the problem is that you need to calculate that what is moving inside the frame or inside that rectangular recess. There is some moving part inside also. So how will you take care of that? So to do that, what you do, that you just change your frame of reference. How will you change your frame of reference? That you also sit with the frame of reference which is accelerating along that. But in order to do that, what you have to do, you have to just apply a pseudo force on that moving element. In the first problem it was that rod, cylinder rod. In the second problem it was the cylinder, which is that mass into acceleration of that entire system, mass into that object, into the, not mass of the entire system, mass of that element, which is the moving part inside the frame, into the acceleration of the entire system. That will be the pseudo force which will act in the opposite direction to that of the acceleration, to that of the direction of acceleration of the force of the entire system, and then you apply the Newton's second law, both in terms of force and the moment. Are you able to, are you okay with this?
Yes, sir.
Okay. So before going into the next problem, you just tell me something, which is the friction was there, but let me see. That is fine. Let me see if I have that problem somewhere or not. It will be easy to. One minute. So these type of problems will be there in your end semester. Okay. So this type of problems again I solved yesterday, right? One, like the last class I solved one problem something like this, I guess. That the velocity was in the other direction. We have to solve it using that I remember I solved something like this also in the second or third class. These also someone asked that the crank IC engine problem. It's basically. And again, this problem is also important, which is Coriolis component of the acceleration. Did I talk? Yes or no? That should be there. The Coriolis component of the force. So let me first go through there and then go through the question which I wanted to tell you, and then I'll see if I can do something. Yeah. So look at this figure very carefully. Are you able to see the screen, by the way? Yes,
Yes,
right?
sir. Yes.
So it says that where is the problem? That question number 3. Okay, and this question will be there in your end sem, by the way. So I am just giving you 1 marks free. Okay. So it says that a sphere is set rolling on a horizontal surface. See figure 1. A sphere rolling on a horizontal surface. The coefficient of friction is large enough to ensure that it's rolling without slipping. That means this point which is attached with that thing, surface, if the surface is not moving, then that point is also not moving for that instantaneous time, but all other points are moving. Okay, and it says that the velocity at the center of the sphere is v. Then what is the velocity of point A, the topmost point of the on the sphere? Can someone tell that velocity of the center of sphere is v. It asks that what is the velocity of this point, the point of contact?
0, sir.
0, right? Because it's, and so if the velocity is 0, what friction coefficient you will apply? Kinetic friction coefficient or dynamic friction coefficient?
Static friction force.
Static friction coefficient, exactly. Yeah, so that means this point the velocity is 0 and this center is the velocity is v, and you have been asked that what is the velocity of that point a, which is the topmost point of this. So what will be the velocity?
2v, sir.
Huh? How much?
2v.
2v. Why?
2v.
Yeah, why?
You can solve it by taking pole as a contact point. By taking contact point as a pole.
So that means you are not using the correct word. So that contact point will behave like a instantaneous center
Pole.
of zero velocity.
Yeah, instantaneous center of zero velocity.
Yeah. So that means as if the entire thing is rolling about this point, this contact point. Okay. So if you see that this entire thing is rolling about this contact point, then so the cylinder has a radius r, let's say, and the center is at a distance which is r by 2. I mean the center is at a distance which is r, right? The distance from its surface to the center is r, and the linear velocity is v. So what is the angular velocity? Omega is equals to v by r. Am I right?
Yes, sir.
Yeah, that means the angular velocity of the cylinder yeah. So the thing is, what I am trying to tell you is that you have a cylinder, fine, and then the velocity of the cylinder along this direction is v. This is v. Sorry. So if this is v and this thing is just the free surface and this is your point of contact, the point of contact to up to this distance is r. So what is omega? Omega of the cylinder, omega is equals to v by r. So what about this point? What is the distance from this point to this distance? Is 2r.
2r.
Right? So what is the velocity of that point, va? If this is my point A, it should be omega into 2r, and omega is equals to v by r. So v by r into 2r equal to 2v. My handwriting is too bad in this thing because I am not writing it in other way around. So this is what you should be familiar with. So there will be few questions on that instantaneous center of zero velocity. This is 1 marks I am giving you. And the other marks which I must give you is that which I have not discussed, I guess. Do you know the Coriolis component of the acceleration? The Coriolis acceleration? Anyone?
No, sir.
Coriolis component of accelerations you don't know, right? Okay. So let me do it using an example so that you will be able to get it. And this problem also might be interesting. So it's a pin joint here, and you are just applying some force P of this rod. So what will be the moment at point A? I have told these things multiple times in previous classes. Anyone? This question will also be there in some of the set of your answer.
Minus PL.
Moment, not the force. So let me go to the
Minus P into L.
1 minute. Yeah. So in relation to figure 2, the reaction moment acting on pin joint A due to the load P. It should be 0, right? Because when you will apply the force, it will rotate, and there is no resistance for that rotation, because about the pin joint it can rotate, right? So that means there will be no reaction moment, but there will be reaction force. Fx and Fy, both the reaction force will be there, but the reaction moment is 0 at point A. By the way, I'm just giving you a lot of NSEM question. You don't tell it to the NPTEL team, otherwise they will do something. Anyway, so the other thing which I will do. Oh, okay, I'm getting the same question. So where is that? Yeah. So this is a question which is regarding the Coriolis component of the acceleration. Read the question number 12. Sorry, 14. See, I am just discussing this concept because this might help you in the end sem. Okay. So now you tell me, like, can anyone like see that what the problem means? The question number 14. So you have, are you able to see the full screen with the figure, right?
Yes, sir. Yes,
Okay.
sir.
So block 2, you have some block which is like this. Block 2 is slides towards on link 1 at a uniform velocity of 6 meter per second, as shown in figure 14. This is figure 14, right? Yeah. Link 1 is rotating, so that means you have a rod and you have a slider at some point. The entire rod is rotating about this point, and also the slider is sliding out. Okay, so that block is sliding out. Block is attached to that rod 1. Okay, and this point P is moving outward. Okay, I mean the entire block is moving outward, and what is given is that the link 1 is rotating at a constant angular velocity of 20 radian per second counterclockwise, as it is given. The magnitude of the total acceleration in meter per second square of point P of the block with respect to fixed point O is. So what will be the, when, if the rod is not rotating, then what will be the acceleration? If the rod is not rotating, what will be the acceleration of the block 2? This you have to tell me. Otherwise, I will not show you any other answer question. If that acceleration, if the rod does not rotate, okay, then what will be the acceleration of that block 2? It's just sliding along a rod. So what will be the acceleration?
Zero. Zero.
0, because it is just moving with a uniform velocity of 6 meter per second. The moment rod start to rotate, the the entire scenario will change. How will it change? So now let's see the other scenario, that the rod is not, that the block is not sliding, but the rod is rotating, and the block is fixed at point P. So what will be the acceleration of that block, and the what acceleration it will feel, that block? That you have just a simple rod, and you have something is attached at some point, and it is rotating. So what will be the acceleration of this block?
It will have two components of acceleration as tangential and centripetal acceleration.
So what is the tangential? Uh, so so if that angular acceleration is constant, then that tangential acceleration will be
Zero.
0. Okay, so that means there is no, sorry, if the angular velocity is constant, then that tangential acceleration will be 0, because alpha is d omega dt. Omega is the angular velocity and alpha is the angular acceleration, and alpha is d omega dt. Just like a is equal to dv dt, alpha equal to d omega dt, and it is moving with a constant angular velocity. That means the tangential component is 0. So what will be the normal component, and like what term you call for this normal component of acceleration?
Centripetal acceleration.
Tell. Hello.
Centripetal acceleration. Omega cross R.
So in this case, omega cross r is what? That means simply it is omega square into r, because the omega r are both in the normal directions, and it will that acceleration will again, so that omega is perpendicular to the xy plane. Okay, r is along in the xy plane, so that means omega cross r will be along k, sorry, omega cross r will be along what directions?
X and Y.
Okay, so my question is that, like, what will be the direction of that omega cross r? It will be towards the point O or away from point O?
Towards point O.
Why? Why it should be towards point O? Why not the away from point O? Yeah, you are right.
You assume it is counterclockwise. Omega k cross I gives minus j.
So it's
K cross I is j.
that means omega is equals to some omega naught into k cap. Okay, and r is equals to, let's say, some xi plus yz. So can you just do that cross product omega cross a and tell me what is the direction?
It will be giving minus I minus J.
Minus
I cap minus J cap.
minus I cap minus j cap. That means it is pointing towards the point O. Minus I cap minus j cap is means it's pointing towards the point O. You are right. Now come to the second question, that now that block is also sliding about the rod. As the block is sliding about the rod, it will feel the another acceleration called the Coriolis component of the acceleration, because the block is sliding, but it's and like what will be the direction of that acceleration? It will be along the theta direction. That means, like, what I mean by theta direction is that perpendicular to the rod. So if my rod is like this, then along this direction will be that. If it's rotate like this, then along this direction will be my Coriolis component of the acceleration. And what is the magnitude of that term? It's 2 omega cross v. 2 omega cross v or v cross omega. I need to remember. Yeah. So it's 2 omega cross v. No, it should be 2 v cross omega, I guess. Let me check it 1 minute. Somewhere there only. 1 minute. Yeah, it should be 2 V cross omega, but in this case it is simply V into omega, okay, because it's only 2D problem. So sorry, 1 minute. Where is the thing? Yeah, so in this case it will be only 2V into omega. So what is the magnitude of 2V into omega? So what is the magnitude of the previous one? That omega square into R. What is R? 10 millimeter. Can someone calculate it just like that? So it's 10 millimeter into 20 radian per second. So it's omega square into R. So into that means 20 square into 10 millimeter means 0.1 meter. So what is that quantity coming? Can someone calculate it?
Omega square R, sir.
Just calculate omega square R and then calculate 2 into omega into V. So that omega is equals to 20 radian per second and V is 6 meter per second. So what is that coming? So that 2 V into omega is called the Coriolis component of the acceleration in this case. So it's 2 into omega means 20, 40 into 6, 240. 240 meter per second square, right? And what is the value of omega square R? So it's 400 into 0.1. So it's 0.4, right?
Yes, sir.
So what is
40,
that?
sir. 40.
40, right?
40.
It is
Yes, sir.
400. What is 40? Omega square into R.
Yes, sir. 40 meter per second.
It is 40 meter per second. It is only 100 millimeter, right? So its omega square means 400. 400 into it is 40. Yeah, 400 into 0.1. So it's 40 meter per second square. And the other is 240. So along the normal direction, it is along the normal direction it is 240. Sorry, along the normal direction it is 40. Along the tangential direction it is 240. Can you do the square root of the both and like square and then root the entire thing? That because these two accelerations are acting normal to each other, that means root of 40 square plus root of 240 square means how much?
243.
So that means that should be the answer. So it's 243 point something, right?
Yes, sir.
Yeah. So you need to put that answer. Yeah, someone raised hand. If you have any question, can you tell?
No, sir, it's by mistake.
Okay, okay. So these two questions you should be now like ever, and everything else is not that difficult, I guess. So 1 minute. Now I will go to the assignment problem. Now this problem, that a log of wood of mass m is equals to root 3 kg is tied with two cables and is released from the position shown in the figure from rest. What is the what is the angular acceleration of the cables at this instant in radian per second square? How will you approach the problem? Anyone? It's asking that what is the angular acceleration of the cable at this instant. Both of them are 60-degree angle with the log. It's like this thing that you are just imagine yourself, you are sitting on that log and both the ropes are like rotating about that dotted line. It has some mass which is root 3 kg. It's a very simple problem, right? This type of questions will also be there in your exam. Again, I'm telling you. Okay, so you should be aware. Though I will not discuss it in detail, these might also be there. And this type, yeah, not that difficult. So let me see the solution. Solution is very simple as far as I can see. This is 3 meter. So what is the force along the x direction? Like check how we do the coordinate system. Coordinate system, the x axis is at an angle 30 degree with the horizontal. Okay, so how will you do that? So it will not be the exact mass of the log, rather some component of the mass of, like rather some component of the weight of the log will work as the net force along the x direction, which is coming as mg by 2, that is mg cos 60 degree, and therefore the acceleration is just g by 2, because the total force is mg by 2, m is the mass, so definitely the acceleration is g by 2, which is 5 meter per second, and alpha is equals to a rectilinear acceleration divided by the length. That length L, what is the length L? That length L is the length of the rope. That is something which is important. If you do that, it will come as 5 radian per second. Is that fine? Now if you have any questions or any queries, you tell me. Okay, fine, right? Hello.
Fine.
Okay, then again we will meet on the next week. Hello sir. Hello.
হ্যালো,
হ্যাঁ
শোনা
হ্যাঁ
যাচ্ছে?
হ্যাঁ 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 হ্যাঁ
হ্যাঁ, বলছি যে আমি তোমাকে একটা পাঠিয়েছি,
হুম
লিঙ্ক পাঠিয়েছি। তুমি ওই বুফেটার সাথে ড্যারিশ কথা বলেছিল,
হুম
ঠিক আছে?
হুম
ওই he has a lot of interesting work on particle-laden turbulence, DNS টাইপের। তো
ওকে
আমি ওর ওয়েবসাইটে there is a mention of a Facebook page,
হুম
যেখানে ওরা বিভিন্ন জায়গায়, মানে all of not just their group, সব জায়গার